Okay, can people hear me now? Okay, great. So I just wanted to welcome everyone. Many of you have been here all day as part of a 3-day workshop in communicating science. This is the end of the first day. Some of you are coming just for this event, which we're very glad to see you. And we'll be hearing from two very eminent science writers, Casey Cole and then Greg Critser. Casey is a professor at Annenberg School at USC. She was for many years a science reporter and columnist for the Los Angeles Times, and she's the author of 8 books, I think, 8 science-related books. I think the most recent with a great, great title, Something Incredibly Wonderful Happens, about Frank Oppenheimer. And Casey is also a member of the advisory board for the Center for Communicating Science at Stony Brook University, which I'm a member of, and we are the people who are helping put on this workshop today. So we're kind of dedicated to the idea that scientists need to learn to communicate more effectively with the public about their work and why it matters. And Casey's going to talk about some of the challenges of that and of communicating science. And with her is Greg Critser, who is another very eminent science writer. Greg's written a series of books about some of the public health obsessions, you might say, current obsessions of Americans. They include, maybe the best known of them is the book Fatland, with the subtitle being How Americans Got to Be the Fattest People in the World. Is that the right title, Greg? Yeah. And then he also, you'll know what these titles are about, Generation RX, about the use of prescription drugs, and the most recent, which is called Eternity Soup, the quest to end aging, right? Is that basically right? So I'm just going to turn it over to them, and I think we've got a great evening in store.
Thank you. It's fun to be here. I'm told I can wander around. Is that true? Can everybody hear me? And I have a little remote. I did want to mention, just because I'm always introduced as being from USC, but I did spend 5 years here at UCLA, actually housed in IPAM, which I think is still here, the Institute for Practical and Applied Mathematics. Pure and applied mathematics, yeah, and actually, and taught the freshman cluster class in small title, The Origin and Evolution of the Cosmos and Life. So we just covered a few things. Anyway, I'm going to talk to you a little bit about the difficulties of communicating science. It's not the same as any other field. I feel really strongly about that. And I'm going to tell you why. It definitely puts some strange requirements on the part of the translator. So that would either mean you when you're doing your translating, or it would mean a science journalist or another journalist who you might be talking to, things to keep in mind. So let's see how this works. It works. This is obviously the first, PowerPoint. This is the only weird transition. Don't worry. I didn't get carried away. To start with Frank Oppenheimer, just to say that artists and scientists are the official noticers of society. The people who notice think that other people either have never learned to see or have learned to ignore it, and then communicate those noticings to others. It's really interesting for those of you who haven't read Alan Alda's book, Things I Learned While Talking to Myself. The end, as I remember, is all about the importance of noticing, and it's just absolutely key. The problem is that when scientists are out noticing what's going on in nature, they're looking at data points, and they already have to do a certain amount of translating. So the person who's then communicating has to translate what is in effect already been translated. And so there's a lot of garbage that gets in the way. And I hope you can see these. This is the sort of typical, thank you for granting this interview, blah, 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 jerk, imbecile. We often wind up like that, unfortunately. For the scientists, and I could show 100 slides with the same basic quote, there's no excuse for not being able to communicate what you do. I mean, this just happens to be Einstein. Most of the fundamental ideas of science are essentially simple and explainable to everyone. And the one I like even better from Schrodinger, if you cannot in the long run tell everyone what you've been doing, your doing has been worthless. For science writers and people who are dealing with them and want to look inside the sausage factory, this is basically what we have to do. These are some rules. I mean, when that book, The Rules, came, so lie, cheat, steal, be stupid, don't trust anybody, waste people's time. So I'm going to go through these, but I'm mostly going to spend time on lying, because lying is the most critical one that we do. This was my loss of innocence. I was a writer at Discover magazine. I had just started, and one of my great mentors was Vicki Weisskopf of MIT, wonderful physicist. He wrote this book called Knowledge and Wonder, and I was writing about small differences and big differences, and one of the examples he used was the electron. Sodium versus neon. Difference of one little electron makes all the difference between an inert gas and chemically reactive metal. So I wrote this up in my column, and a fact checker said, you can't say that, that's wrong. I said, what do you mean? They said, well, what about the proton? That's also different. Oh, I didn't know what to do. I was a baby science writer. I called Vicki, and I say, you lied. How do I deal with this? And this was his advice. You always have to lie a little to tell the truth, which I takes very seriously. And in fact, I was amazed. I used to write a column for the LA Times called Mind Over Matter, and I did write this one about how we lie, and I thought I was going to get in trouble, but actually everybody loved it, so it was fine. There is something in here about honest descriptions of scientific ideas always remain elusive, because an accurate description lies somewhere between the crisp clarity of equations and the fuzzy familiarity of metaphor. We have our own, well, those were sins of omissions, first of all, the proton. Those are the easiest lies to deal with, things you don't say. Scientists always want you to have their colleagues and their titles and their funders, and we don't care about any of that, so just forget it. And I thought this was very well said by Niels Bohr. For those of you who are not physicists, all it means to say there's an uncertainty relationship between truth and clarity is that the closer you get to one, the more accurately you can measure it, the farther away you are from the other. And I'm going to give you a lot of examples of that. But if I gave you every piece of information about everybody in this room, it would just be noise. So you have to make this trade-off. And physicists, I find, lie all the time, and in ways that are not the right kinds of lies. So this is Lenny Susskind from Stanford, and he knows I have a particular problem with this lie, where antiparticles are described as the same as a regular particle, but with an opposite electric charge. If you ever try to understand anything about antimatter and how it works, that immediately makes no sense, because opposite charges don't annihilate. So it's the kind of little lie that actually throws you off. Here's another one that I bumped into. I was trying to explain to my father. He wanted to know what the force was he felt when he stubbed his toe, stubbed his toe on the mantle, on the whatever it is you stub your toe on. And because I was writing a lot about force particles and matter particles and what the difference is, and basically it boils down to a half-integer spin versus integer spin, and then you start really think, well, there really is no such thing as particle spin. It's really a metaphor. It was described as a classically undefinable two-valuedness. We put that word on it, and if you try to make sense of it, it doesn't, because you have particles like electrons that are point particles. They have no dimension. There's nothing to spin around. It can't spin. So these kinds of uses of language really throw us off a lot. Okay, so what if we forget about trying to translate into English at all and just communicate in jargon? There are times where that's really useful and gets you to the point. If you've ever been sailing, I remember one time when we were about to run aground with a bunch of very novice sailors, and the skipper said everybody hike out over the lee side, but half the people didn't know what that was, so we ran aground, and we were there for quite a while. So jargon can be useful. The problem is that many problems. One problem is that jargon changes. Okay, so this is Isaac Newton and how he's writing, and this is, basically a scientific writing, and now we might add something concerning a most subtle spirit which pervades and lies hid in all gross bodies, etc. By force and action of which the spirit of particles of bodies attract one another at near distances and cohere. Obviously, he also used equations, better words. Compare that to, this is from Paul Weiss. Imagine Newton coming across, the products of photoreactions of conjugated organic molecules may be allowed by selection rules, but not observed in solution reactions because of unfavorable reaction geometries, and so forth. It depends on what field you're in, whether or not the jargon is going to make any sense to you. So That's not going to solve our problem. We also have our own jargon as journalists. These are some of them. They're not quite as cruel as they seem, but we know what they mean. We don't care if you do. Okay, so what about just using equations? I mean, let's forget words, let's forget jargon. What if we go directly just to something that we know is true? No lie, okay, equals mc squared. It's a little oversimplified, but it's basically true. Which gives you more information? That, or, this is from Phil Morrison's Ring of Truth. It's one of my favorite examples of equals mc squared. Alter a wind-up toy, unwinds and lightens by 1/billionth of the weight of a dot of an I. That would be a printed page, of course. A car burns tank full of gas and plenty of air. The total weight lightens by 10 dots weight. Thermonuclear bomb explodes and the total weight is reduced by 1/4 of an ounce. The sun shines for 1 second and loses the weight of 24 ocean liners. That is an image you're not going to forget. That is E equals mc squared, big time. So which is the preferable? This is a little bit of a lie in some sense. I mean, it's not absolutely as accurate, but I think it's a lot closer to the truth, going back to Bohr. And Bohr, again, who said when it comes to atoms, language can be used only as in poetry. We're interested in not so much as conveying facts, but with creating images, especially when we're trying to communicate with the general public. Okay, so, you know, we're creating images with our minds, we're using metaphors. Why not just go straight to the images? Maybe that would solve everything. Well, here are just some images. I actually plucked this one off from this group here, our hosts, so maybe one of you is familiar with that. But the rest of them, black holes or Feynman diagrams or strings. You know, we make all these things up to try to make things clearer, but do they help? Uh-oh. Did I just turn that? Oh, no. Okay. This is something that a friend, Ronald Hoffman, who I do a lot of work with, he's the Nobel laureate in chemistry, and he talks a lot about imagery, and he says, okay, here's one of his questions. What does camphor look like? Well, all of those representations are correct, and so are all of those. So what does it look like? Well, you know, it's a matter of context. It's a matter of what's useful. It's a matter of what you need to know to see what it is you want to see in that particular context. So this isn't going to help us out either. Basically, there is no one size fits all. It's a matter of judgment. It's funny, I just cleaned out 20 years worth of files, and I found an old paper by Vicky Weisskopf about talking to the public about science. And I just thought this was interesting. He said, in many cases, scientists oversimplify what they shouldn't and don't simplify what they should. And I think that's really, really key. Sometimes they talk down to us and make things so overly simplified that they make them more complicated than they need to be. So obviously distillation is not the same as translation. I learned something really important from a mathematician, Ingrid Dobche at Princeton, I was writing about. She was a MacArthur Fellow, and so they got together with other MacArthur Fellows in other fields, and she was talking about a conversation she had with a poet, and how for the first time she understood what mathematics was. She said, you take a big, complicated subject, you distill it down to its essence, and you communicate it. And I thought that was really beautiful, but I thought that interaction between the poet and the mathematician was extremely nice also. So that's what we do. So that's basically lying. The rest I'll go through pretty quickly. I get in more trouble about cheating than anything else, but why do we cheat? We cheat because there's no such thing as science news, unless you read The Onion. This is one of my favorite Onion pieces, Dolphins Evolve Opposable Thumbs. But as you know, science is an ongoing process. So what does it mean that there's science news? It means that somebody published a paper in a journal. It means that somebody put out a press release. It's an artificial marker. Science is ongoing. It's always happening. If you're in the news business or the magazine business, you have to make up some kind of reason to have it in there. But we all know that's not true. So that's what I call cheating. When I was at the Los Angeles Times, I cheated like crazy. In fact, I realized after 4 years I had 40 front-page math stories. Obviously, I had to cheat a little in order to do that. This one example was about the book that claimed to show a link between IQ score and race, which was just full of the worst use of statistics. So I got to write 3,000 words about statistics, which was pretty good fun. This one, which I had even more fun with, this was many years later. I wanted to write a very serious story about the problem of getting young people involved in science and the stereotypes about scientists and how to convey the idea that they were, sorry, I'm going to have to drink something, that they were really all kinds of people. Well, my usual editor, the column one at the LA Times, just had absolutely no interest in this story at all. It turned out that the editor of the calendar section was very interested, and this was just after the Mars rover landings. And a lot of these, it's a terrible picture, but a lot of these people were on TV. So I did a story about some of the engineers, the team that really worked on these rovers. And the woman at the far right over here, she was a Laker girl and a born-again Christian. The black guy next to her is a farmer from Kansas. The lead guy, worked in a crystal store and was this kind of woo-woo hippie for a while. The Asian guy who everybody saw on TV said when the cameras weren't on him, he was playing with his Walkman. Actually, only the young woman on the left from Pasadena was kind of, you might call normal. But I had to do it in calendar because, the people in my department, in my usual department, were just not interested. And I actually had a long history of that. Before I became a science writer, I wrote about marriage and families and kids and politics and all kinds of stuff. Sorry about that. So when the New York Times asked me to write a whole series of columns, I got my own column. They used to do that for a series of weeks, and I wrote them all about physics. And so suddenly I was a science writer. So I wrote about resonance in terms of relationships and being in and out of tune with people and entropy and why your stockings run and your rooms get messy and on and on. But it was definitely, getting in a back door. So we almost always have to do that, go in sideways. That's what I call cheating. Stealing, again, why scoff? I was talking to him at one point and said, but gee, Vicki, I steal all your best ideas. And he said, the real sin if you hear a good idea and you don't steal it. He didn't mean to copy somebody else's work and take credit for it. I do find that people often don't go to the trouble of paying attention to what other people have done before you. There are a lot of smart people out there, scientists and non-scientists, who've really gone to a lot of work to try to explain difficult concepts, and people should take advantage of that. This is just a group of physicists. This is from a former generation who were popularizers, vulgarizers. When I started working here at UCLA, my astronomer friend said, oh, you're a vulgarizer, right? Anyway, and these are some of our more recent people, Lisa Randall, Frank Wilczek, Leon Lederman. And again, this is just physics. There are many, many examples. So there's a lot to be learned from what people have already struggled with and already done. So yeah, you should build on the quotes and ideas of others, and especially for scientists. There's so many of your colleagues who've already written just beautiful, wonderful works that you should definitely use them and be familiar with them. And they do steal our stuff too. I was writing about brains theory. Not neuroscience brains, but membranes, lower dimensional membranes on which our higher dimensional universe may live. And I suddenly understood why it is that gravity doesn't get stuck to the brain. Anyway, I said to one of the Savas Dimopoulos at Stanford I was working with, I said, so you mean gravity leaks off the brain? And he said, yeah. So next time, a couple months later, I saw he'd published a paper with the title Leaky Gravity. So I thought, okay. Dare to be stupid. I think this is one of the most interesting, not just for writers, obviously, but for scientists. I've never known a scientist who doesn't feel that they're doing their best work when they're most confused and when they're absolutely at the edge of what they know. And so this is often what we feel like. We're at scientific conferences, lots of babble going on. Oh, what are you talking about? I don't know. So I got a good advice from a mathematician. You can see I wrote a lot about math in the old days. And this was a guy at the Courant Institute and who was tying 9-dimensional knots in 10-dimensional space or something. And when we were done, toward the end of the interview, I said, so let me ask you a question. Is it really true that scientists do their best work when they're 25 or under? And he said, look, I'll tell you what happens. Math is really hard. You sit, you read a line of equations, you don't understand a word of it, you read it again, you sit there all day, and you just feel stupid. But later you get to be a professor, you get an office and a secretary, you don't want to feel stupid anymore, and you stop doing good work. So I think that's really true. And I had the misfortune or honor, whatever, of being the first writer in residence at MSRI. Anybody know what that is? It's a Mathematical Sciences Research Institute in Berkeley. They like people to call it emissary, but of course everybody calls it misery. And I sat around for the first week or so not understanding anything that was said to me, but I did notice that the last person I talked to always made more sense than the person before. And I realized that what was happening was something like this. I was picking up these little bits, and then, oh, I see, I get it, it's a cat. But most of the time, I was walking around in a state of total and utter confusion. And it's really important, if you're ever going to really understand something, that you allow yourself to feel confused, because otherwise you'll never get there. And I actually did write about this for the Columbia Journalism Review, why we have so much trouble getting science into mainstream newspapers and magazines. And one reason is that most editors are very smart people. They have a lot of awards, and they're just used to being the smartest people in the room. Science makes them uneasy because they feel stupid. And they don't understand that not understanding is okay. So when you say, well, nobody understands dark energy or nobody understands this, that's a good thing. I mean, that makes it an interesting mystery. That doesn't mean that you should never write about it. So don't trust your sources or your editors. Boy, this is for all of you, too. Somebody tells you something, even some great scientist, some senior fellow, and you just take it and you run with it because they have some great authority that they're working with. I have had more scientists tell me stuff that is just blatantly wrong. That doesn't mean they were stupid or that a lot of times people just misspeak. And you just have to, it's something you really have to be careful about. As for editors, I don't know where to begin. This is Moses, the God. No, I can't dumb it down anymore. Or even one I like better, we prefer to call it editing. It's how they try to destroy what we do. This is there's so many examples of this. This was a story I wrote for The New Yorker about physicist Janet Conrad, who works with neutrinos. And she has this big detector. You know, The New Yorker, if you've seen the magazine, they do all these set photos. So they had one of her in a ball gown in an accelerator. And this was the other one. And I just happened to be in New York the day they were closing the issue. And the caption that they had written was, there's a cot there that the photographer had put. Janet Conrad sleeps under her particle detector. I mean, no way. They just made that up. Absolutely. Because the photographer made it up. So, and please remember that writers have nothing to do with captions or headlines. Often get us into trouble. This was just another funny one. Jackie Barton at DNA, at Caltech, working on DNA, and they put this on the front page of the LA Times with the caption with a model of DNA, and she looked at it, she said, my 6-year-old could have told you that wasn't DNA. So. And even if you're, scientist publishing, I just love this partly because Lawrence Krauss is somebody who cares about his public image, and here his own publisher is saying that he's risen to be one of something of the great paradoxes of modern cosmetology. So the publisher didn't know the difference between cosmology and cosmetology. You can let absolutely nothing go. Waste people's time. This is really important for a lot of you scientists who are going to be trying to communicate not only your own work, but through other people as well. Good science communicators do enormous amounts of work to produce something that may look very small to you. So most of that reporting is going to go unused. And the time it really hit home to me was I'd done a very complicated article on quantum teleportation. This is really leading into quantum computers. I got a huge amount of help from John Preskill at Caltech, who is one of the most generous and clear and great explainers. Then I ran into him after the story was published, and he kind of wandered away, and I said his wife was something wrong, and she said, you never mentioned him in the story. that kind of thing happens a lot, that the person who is most helpful doesn't get the credit. But the point is that you have helped yourself and those writers to understand that stuff for the next time. It's part of the body of knowledge that you need to be able to say anything with any kind of authority at all. So we do a lot of work, and you need to do a lot of work that will never, ever, ever see the light of day in any form whatsoever. Quote out of context. I just say this because, when I started getting quoted in magazines and newspapers, I realized it was always out of context, and then I realized, oh, by definition, anything you say is going to be out of context. Now, sometimes the mistakes are really egregious when people misrepresent what you say, but it's never going to be a complete thought, never, because you're never going to get to put in your qualifiers. Make arbitrary calls. This is an odd thing, too, about, you'll notice that one of the ways we cheat in writing about scientists is to write about personalities. It's not really cheating. It's because people are interesting, and the way they do science is really interesting. But it's always easier to get a profile rather than a story that's just about straight science. But who are you going to profile? Let's say I have, 15 string theorists or 18, people working here. A lot of it just has to do with who you sit next to at lunch. And it may have nothing to do with anything except that. There are a lot of people who are good and who can help you out. Don't expect anyone to understand you or believe you. So this is another little lesson I learned from Vicki Weisskopf. When I was first trying to understand how you could have curvature in four-dimensional space that somehow led to things behaving as if they were in a gravitational field. And he finally said to me, this is one of the great physicists of all time, he says, I don't really understand it either. And he told me this story of the peasant who tries to learn from an engineer how the steam engine works. And the engineer goes through all the explanations, and this happens here, and you put the coal in, and it makes steam, and it heats up, and blah, blah, blah. And the peasant listens and understands every word and then says, but where is the horse? And he said, and that's how I feel when somebody tries to understand curved space-time to me. Okay, I follow your argument, but where is the horse? And the reason I think that this is, really important is why should people, let me see if you can read this, why should people believe you? And I'm starting to wonder whether the physicists are pulling some kind of elaborate scam here. Starting to wonder whether they don't sit around their $23 million atomic accelerators all day, drinking frozen daiquiris and shrieking, there goes one now, and then laughing themselves sick. Why should people believe you when you say things that really don't seem to make any sense? And then they show us pictures like this and say, oh, we've discovered this, that, or the other. I mean, please, give me a break. There's a couple of drunks sitting on the stoop, and one of them says, quarks, neutrinos, mesons, all those damn particles you can't see. That's what drove me to drink, but now I can see them. But there's a really important point here, and I think it came up especially in the intelligent design so-called debate, but in writing about it. People will always say that what intelligent design argues is that evolution is simply unbelievable. I mean, anybody can see that. You can look at what we all evolved from these simple forms. It is, at some level, unbelievable, as is the fact that there are people on the other side of the world, to whom that is down and this is up. Or that a cloud, weighs the same as a 747. So there's lots that's unbelievable in an intuitive sense, but we know it's true because of evidence. And that's something that you have to acknowledge to people. Look, I know this doesn't make any sense, but we know it's true because that's really, otherwise people just feel stupid. They think there's something wrong with them, that they don't get it, when actually it's, just plain hard to get. You always make mistakes, scientists and the writers. Big reason that nothing's written in stone anymore because there are 2 M's in commandments. I actually wrote my last column for the LA Times. It's all about the mistakes I had made. Some of them were pretty amusing, but it certainly does happen. And the great thing is that you can always correct yourself, and you should. So avoid hardening of the categories. An artist friend of mine, Bob Miller, used to say the most dangerous disease afflicting humankind is hardening of the categories. The joke doesn't work that well anymore because nobody talks about hardening of the arteries anymore, but it used to. And some of the examples of that are, Larry Gonick, a cartoonist who writes about physics, computers, all kinds of things. Tom Stoppard, who writes amazing plays about mathematics. Roald Hoffman, who writes about chemistry in really weird ways. This one is about Jewish lore and chemistry, things like what is natural and unnatural, and one of my favorite books, Physics and Philosophy. Some more recent examples, Alan Alda, QED, one of the best plays about Richard Feynman and quantum mechanics, and the new play, Radiance, with Marie Curie. And this guy is from Stanford. He started a whole movement in doing raps on biology that are actually quite good, and now they're in many, many fields. Rapping has become huge. Another composer who just did a wonderful series of symphonies for the Griffith Observatory. And this is what I do, but I just wanted to show you, since apparently I have it here, is the website. Never mind, because that didn't come out too well. So what the origins of this thing is, I feel that anything you do to bring science out and connect it to the rest of humanity, the rest of what we do, the rest of the way we look at things, is very, very valuable. So years ago, I had a book coming out that was about nothingness. It was called The Hole in the Universe. I wanted to read at the Cornelia Street Cafe, which is this wonderful place in New York where the vagina monologues originated. Robin Hirsch, the owner, told me I wasn't famous enough. I got Walt Hoffman, who had a Nobel Prize, et cetera. He wasn't famous enough. We got Oliver Sacks, who we both know. Now we were famous enough. And this program, Entertaining Science, goes on to this day in New York, first Sunday of every month. So if you're there, Cornelia Street Cafe, it's a great program. In fact, we just had a reunion last year for my new book with Walt and Oliver and myself on a different subject. When I moved to LA and Disney Hall opened, they started with a creation festival. So one of the first pieces was Haydn's Creation. There was a musicologist who gave the pre-concert talk, but she wanted me to do the creation of matter and the creation of the universe. So we did a 3-night gig, the two of us, which was just amazing, and we were packed and overflowing. So we decided, hey, this should be a regular thing. And now we moved it to Santa Monica Airport Studios. It turned out that people were converting an airplane hangar in Santa Monica into artist studios, and they wanted to bring this program there. So we did. The very first one actually was based on UCLA. Andrea Ghez, who weighed the black hole in the middle of the Milky Way, I was working with at the time. So she did black holes. I had somebody do a scene from Beckett's Happy Days where she's up to here in a hole. We had a French horn player from the LA Phil talk about her 12-foot hole and how that worked. Dark matters, just to give you, Nancy wasn't here, that's why I wanted to show her picture, but we had Macbeth, the Inquisition, and dark energy. It was pretty typical. Balance with a lot of physics from our provost in charge of undergraduate education, ballerina. It was really, and journalism, how to cover the Middle East. What was really interesting was that the journalism students really got the fact that your balance isn't always where you think it is. It's not necessarily in the middle. In fact, it's almost never in the middle. This was another one. This is because Amy Parrish is here, so I had to show this. Political animals, where we had art, guerrilla art, politics, and bonobo politics, and just a bunch of others. Orson Bean was great. It was really funny because we did one on mistakes and how mistakes are the basis of comedy, but also how important they are in doing science. That was Sean Carroll, and then Carol Tavris, the psychologist who wrote the book Mistakes Are Made But Not By Me, on why we never seem to admit our mistakes. And actually, our next one, let me know if you want to be on the mailing list. I'll put you on it. Coming up in September, again, UCLA, that Amy Rowat has a lab here where she treats food as condensed matter. She's a condensed matter physicist, and she'll talk about the physics of dessert, for example, and the guy who invented the umami burger, and then Robin Hirsch, founder of the Cornelia Street Cafe, who told me that I wasn't famous enough to read at his place. So, debase yourself, but never your readers. The reason I say this is, if you're writing for the New York Times for a long time the way I did, and suddenly you can't get published there, and you're writing for the Daily News or something, and you're going, And somebody said to me once, that's wrong. Like, those readers need to hear you even more. And nothing is below. I mean, there's no group of people are intelligent and they want good information, whether they're watching Oprah or the Discovery Channel. It really doesn't matter. Objectivity, highly overrated. We know in journalism, this is certainly true. Scientists certainly care about what they're doing. It's one thing that Frank said, with the strange misconception people have that you have to be indifferent to the truth in order to discover it, which is totally untrue. Emote, that's what a lot of this has been about. By the way, I just wanted to mention, because we were doing so much improv today, that one of the things that I think makes both entertaining science now in New York and categorically out here very different and always full is that everything is improvised. It's free, open to the public, and nobody ever knows what anybody else is doing. So it's completely, and people feel that. It's very, very, nobody is allowed to read ever, anything. Any mode, of course, that's kind of basic. This is Alan will probably recognize this. I was amazed when I saw it. This is a footnote from the Feynman Lectures in Physics, and it's not all of it, but it's pretty nice. Poets say science takes away from the beauty of stars, mere globs of gas atoms, nothing is a mirror. I too can see the stars on a desert night and feel them, but do I see more or less? And so forth. Really, really beautifully written. What is the pattern or the meaning or the why? It does not do harm to the mystery to know a little bit about it. For far more marvelous is the truth than any artist of the past imagined. What men are poets who can speak of Jupiter if he were like a man, but if he is an immense spinning sphere of methane and ammonia must be silent. I always thought that was so pretty. So, emote. Frank Oppenheimer used to talk about he'd take his students to the junkyard to look at car parts, and they said, we want to learn about the stars, because they wanted to be moved. So I will leave you with a Frankism. Understanding is a lot like sex. It's got a practical purpose, but that's not why people do it normally. So it's not why scientists do it. It's not why you should do it. In addition to talking to you a little bit about the problems of communicating science and how I think they're special and have special requirements, I was asked to talk about the future of science writing, about which I actually know almost nothing. We know that as it exists, it's almost gone. We still have some very good magazines. Newspaper science sections have almost all but disappeared. But I know that students all over the place are reinventing it in very interesting ways, and I wanted to show you just one of them. This was something that happened that was the real categorically not. At USC, there's this program called the Annenberg Fellows for graduate students, the best in 3 schools, cinema, engineering, and communications. It may seem like a weird mix, but so really all I did was to take some students from my group and introduce them to someone in another group I'm part of at USC, which is game theory and human behavior. It's a part of mathematics that most people don't know about. This is what these young journalists, at just 4 minutes, came up with. I think it's part of where we're going. It's a wonderful narrative, and it's a lot more profound than it may originally look. Let's see, how did it was down here. Yeah. I think this kind of storytelling and personality is going to be extraordinarily important in all kinds of communication. And then I'm going to turn this over to somebody who actually knows something about the future of journalism. Okay.
Wait. All right.
Can you see that one?
I love giving her presents because she has such fantastic reactions.
That was Robert, Lisa's boyfriend. He gives her a new musical instrument each year for her birthday. This time, it was an accordion.
I screamed when I opened the box and realized it was an accordion.
She just was so moved that she just kind of fell on me and kind of hit my face accidentally. And she was laughing, half screaming.
That really was a great gift. I had so much fun learning to play the accordion that Emily and I started talking.
We should go busking!
And so we started thinking about why people give money to street musicians. What motivates them?
But first, we turned to an expert for advice.
It's not clear that we have, one answer as to sort of why a person gives. So what we know, whether it's a social norm, whether it's a psychological norm, or it's some rational behavior that motivate, or some evolutionary behavior.
That was Rajiv Maheswaran, a scientist who specializes in game theory, a mathematical way to look at people's motivations and choices. Game theory looks at what drives people to act and how to change the rules of the game so that they act differently.
So what are we going to do today?
We should go to a street corner and I could play the one chord I know and see if people give us money.
People will watch. People are going to watch you make a spectacle of yourself, no doubt.
And point and laugh.
Yeah, but they're going to roll their eyes and walk on by.
With Robert's vote of confidence, we set up shop in front of the Trader Joe's grocery store.
My heart is beating really fast. We're in Silver Lake. I've just strapped my accordion on, and we're going to see if an amateur who has never taken an accordion lesson in her life can make some money and not look like a complete idiot. Starting...
Caller coming down the street.
Oh my gosh. Okay.
This is a prime candidate for donations. Starting...
15 minutes is starting now.
Just a lot of these people look, they look really busy. Very focused, very dedicated to their Sunday shopping.
They're like, get eggs, get milk, go home.
Yeah. Okay, about 4 people just passed and no donations. We also have competition from a homeless man. How about a whole quarter?
Yeah! What compelled you to give us money?
Oh, I've never heard anything so beautiful in my whole life. I'm going to give you 55.
Thank you!
There should be a lot more money in there. I don't know what's wrong with people.
You're just having a weird time.
I don't get it.
much.
After 15 minutes, 90 people walked by.
And only one person donated. 55 cents.
And I think she was definitely covered under the crazy person who gives an eccentric amount of money.
No, she was sane. She was just altruistic.
She was so sane she was crazy.
She gave the homeless man more money than she gave me.
I know. So,
But
all
we
right.
still didn't know why people would give to us, a homeless man, or anyone on the street.
Rajiv had some suggestions on how to change their incentive to give.
How do you change the rules of the game? So one thing that people tend to do is they tend to follow expected behavior. So what I would do is that right as they're walking by, I would have Emily come up and give $1 and walk by right in their view. Like when they're like 10 feet away, have Emily come up and drop $1 and see what the change is. Have 90 people walk by. I would
To
suspect-
produce the best results, we needed to recreate our experiment with the exact same elements as much as possible.
We returned at the same time on Sunday, wore the same clothes, and lucked out with the same cloudy weather. And the same untrained accordionist.
We called on our friends Caitlin and Arzu to act as motivators in round 2.
Hey, the homeless man is here.
So exact same conditions. The parking lot is totally jammed like it was last time. There's Arzu who is on the corner. She's stationed.
Okay.
Operation Altruism Game Theory. Go! We pretended to act surprised and delighted every time our friends gave us money, which was about every 30 seconds.
Thank you so much. Thank you. Thank you for donating.
And then there were the real surprises. Donations from people who didn't already know us.
Thank you. That was really good. Wow, we just got $2. Thank you, donation.
The first actual gift from a stranger created a domino effect of giving.
That worked. And saw them. Oh my God, that was so good. Wow, thank you. Look at all the money we have. Wow, we have a lot of money.
We do, actually. I can do
After 15 minutes,
We made $7.
Another important thing in game theory is do the people make their actions at the same time? Or do they make it in a particular sequence? So there's a whole other class of games called leader-follower games where one person acts, then another person reacts.
We took Rajiv's advice to view the experiment as a leader-follower game.
each passing stranger had 2 choices, give or don't give.
As the leader, we had 2 choices too. Interact or don't interact.
When we chose to place motivators on the scene, more strangers chose to give. But can we really be conclusive that this is why they gave?
Other factors, like the homeless man who stands in front of the Trader Joe's every day asking for money, could have affected their choice to give or not. Rajiv pinpointed the ultimate question for game theorists, or for anyone trying to change the world.
How do you construct rules and consequences such that you can keep society in a better state?
We learned that you have to be careful with constructing those rules.
Ultimately, game theory can be used to influence social situations, for better or for worse. That was fun. Yeah, although I think I'm going to sign up for some accordion lessons.
And I'm going to try and get that song out of my head.
Well, thank you for listening. I think that was really they did that pretty much in a couple of days, and obviously could be more tightly edited. It's not a perfect piece of work, but I thought it was a great example of just what some students who don't know anything about science or have had any exposure whatsoever can come up with just by having conversations with a scientist. So with that, to give some idea of where I think we might be going, I know that where my students get their information is all electronic. It's Twitter and it's blogs, and it's a whole other world that my friend Greg Critser knows a lot better than I do. So I invited him to come up and talk a little bit about. Greg does some of the best work in medical, pharmaceutical writing I know, and he's a great teacher. So I was going to let him talk to you a little bit about that.
Hi, good evening. Thanks for coming out on a Wednesday evening. Let's see if I can first find my little...
Down at the bottom. Yeah, just take the cursor all the way to the bottom. And it will...
Oh, I see. And then it will tell me... Oh, I see.
Okay, so yours, there you go.
Okay. This will make sense in a few minutes. My specialty is I like to tell stories of how big public health problems came about. And so my first book was about obesity, which I pointed out to Americans that almost 2/3 of them were either overweight or obese, so that made me a lot of friends. But I was lucky with that book. When they sued McDonald's, they used it as an exhibit in the lawsuit, which frightened me to death, but my publishers, of course, thought was great. It was the best thing that ever happened to them. My second book was about prescription drugs, and it was a similar fundamental question. Why is it that we doubled the number of prescription drugs that we use over a period of only about 15 years? So try to take that story apart. And lastly, the new book is about aging and actually the quest to end aging, the scientific quest to end aging. And so that grew out of the observation, obviously, that as a society we're growing older, and we being human, we really want to resist that, right? So that's the examples of what I write about and what I like to write about. I see big science and medical stories as a narrative. Somebody did something. So in the case of obesity, yes, food got cheaper, but why did it get cheaper? Well, there's actually a specific person in the 1970s who got an idea about how to make corn syrup cheap and changed government policy about it. So I dig very deeply into the actual people that make these decisions. And it's made me appreciate, I think, scientists a lot more because of the process that they have to go through. But my use of social media now, but really the internet has grown just like all of ours has over the years. First, as someone who kind of nibbled around it, it made things a little bit easier for me, and then slowly worked various kinds of social media into my reporting and also into the writing. This is a good example of it here. But let me just tell you a little bit about my background as a science reporter, which is that I wasn't one. I had almost no interest in science. I was a history major here at UCLA. I was a freelance journalist. I was interning at a very small newspaper in Pasadena, California, the Pasadena Star News. Many people use it to line the bottom of their bird cage with. And but my editor one day said, we got this, there's this guy over at Caltech, he discovered the quark, something like that. He didn't know what he was talking about. His name is Gell-Mann. Go over there and do a profile of him. Now, of course, this was Murray Gell-Mann, one of the preeminent physicists of the 20th century. And of course, I had no tip-off about the personality issues. So I, of course, go over there, and I'm sure I had an alternate agenda, like a girlfriend who went there or something, really scientific like that. And he granted me an interview, and I went into his office, into the great man's office, and I sat down with a pad and I started asking him some inane question, and he looked at me, just the most disdain, and he took the pad out of my hand, and he said, you know nothing, do you? You know nothing. And it would probably be too much for me to ask you to read something, wouldn't it? You know, you don't want to do that. You just want some headline, Quark Man or something, right? So I said, well, you know, this is one of the few times I didn't bridle, my ego explode. And I said, well, you know, I guess you have something there. So he's kind of continued to berate me, and then he went on to rant about the newspaper and how he hated this particular newspaper, and blah, blah, blah. I said, well, I'm just interning there. So he said, well, I'll tell you what, it's getting late right now. If you want to come back tomorrow, I'll talk to you. So okay, so I went away, and he said, oh, read this, at least try to, you probably can't understand it, but read this. And he gave me a couple things to read, and I did my best at the time, and like I say, I did not have a science background, but I knew, I read it, and I think that was really the point. I actually made the effort to read his language. He doesn't speak in you know, his language is numbers and configurations and such, and dynamics. So he was really telling me, yeah, I really want you to speak my language, or at least try to. He's like a Parisian, you know. They're pissed off at you until you, no, they're pissed off at you until you at least try to speak French, and then they're all right, right? But they want to see you trying. So I went back to him, and he sat with me for about an hour and gave me, you know, his story. And looking back on that story, I should dig it up. I'm sure it wasn't very good, but it did tip me off to one thing, and that is that reporting, particularly about science, is really a two-way street. A good science journalist does not have any excuse not to be up to date on the reading of that particular field. Now, that doesn't mean we have to know everything, and I think Casey's point, obviously, is really important one, where it's a straddling of ego and ignorance, right? I mean, you don't want to be too smart, because then the guy's going to think, well, he already knows everything anyway, and you don't want to be too dumb, because they'll act like Gelman did to me. So that part of journalism has become increasingly easy over the years because of the internet, because of various social media. So, for example, with Fatland, my first book, I was always running down to the medical library at that other school, USC, and to look at journal articles. And I'd have to, you know, look up the index and then photocopy them and go back to Pasadena, and then realize I had left one down there or something. That was for that book. And so what that did, and you've got this limited amount of time to report a book, is, okay, I'm spending 60% of my time going back and forth and photocopying things and trying to get through this very dense literature. I've got 40% left to report. Actually go talk to human beings, and particularly scientists. It takes time to get to know them. The second book, Generation RX, that had really changed. Most of my science stuff came from the National Library of Medicine, which, as you all know, is online. You know, what took me a year for the first book took me 2 months. So that ratcheted up that very quickly. By the third, this most recent book, archives had now become online. So it used to be I'd have to fly to any number of cities back east that have government archives to look at, for example, the FDA hearings on Prozac or something. I have to go back there and do it. No, not now. I can find the actual transcripts of a hearing about Prozac from 1990. I don't have to do that anymore. So what does that mean for me as a journalist? I think it's two things. One, getting up to speed on the basic questions to ask a scientist. It's easier, but the expectations are higher. You know, I don't know if Andre Nell is in here, but he's the head of the Nanoscience Center. I did a story about ultrafine particles and heart disease, and I came in and I realized I had read quite a bit, and of course I knew I didn't know that much, but I had read a lot, and very quickly he was in a territory that I didn't know. But I had enough of the language to be able to ask him clarifying questions very quickly. And that would not have happened that quickly. That would have, in the past, that would have taken a lot more of his time and a lot more time me trying to figure it out. You know, it used to be, well, you could play ignorant and expect an entire explanation. Not now. I mean, unless you get somebody really generous. And I've been lucky, both here at UCLA and USC. I've got 3 fantastic mentors who spent a lot of time with me, educating me, basically saying, go read these books and come back and we'll have coffee. And that's rare in the academy, and for many good and bad reasons. So that's kind of how my use of the internet, electronic information, social media progressed. Now, the next step was, how was I going to use it besides taking that and putting it into print, an endangered media, right? And the question came up. I was working on a book. I thought it was going to be a book about laboratory animals. I'm fascinated with laboratory animals. And so I was interested in the mouse. And the mouse, we use around 30 million a year. It's our principal surrogate. Unwilling, I think, but nevertheless is our surrogate. And I was fascinated with that. And so I started writing about it on this blog. This is it's a combination, I call it a mediated blog. So it's not like one where you can write, I really hate my mother today, blah, 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 blah. I hate Janie. This is a mediated blog. So what Science 2.0 is, this was started by a software executive who was a kind of a serial entrepreneur, but he was a science junkie. And he said, you know what, something's missing in science writing, science communication, and I think that is the postdoc. And I said, yeah, that was a strange one. And I said, why is that, Hank? And he said, because these are the guys who are, and women who are kind of bridling to communicate, but they're the last guy on that line of credits, and they're working for somebody else who has seniority over them. But these people really want to write. So he started this scientific blogging, and now it's called Science 2.0, about 6 or 7 years ago, and he just threw it open. He said, if you want to write about your specialty, welcome. What we'll do, because we've got this great social media technology, we can let you write a few articles, write a few thoughts down. We'll kind of review them to make sure you're not completely crazy. And then you can write your own column. Now, the great thing about it is that it's automatic peer review. So you can lay out a theory, and you get enormous feedback. And that was very helpful for me. I'll give you an example. This is one. Okay, so I was just thinking out loud because I thought my next book would be about the lung. I'm interested in the lungs. It's one of our most intimate, besides our skin, our most intimate contact with the external world on a millisecond by millisecond basis, right? So I think I interviewed Andre and a few other people, and they kept coming back to heart disease and smog. Hey, that's just counterintuitive. I can see lung disease, I can see a bunch of other things, even skin disease, but I said, this is really different. I can't get my head around this, but are you saying that maybe someday we will medicate cities so that they're more resistant to smog? Are you saying, for example, that we are, let me see if I could find this. This is, are you saying that we are inhaling a heart attack? Because that really made sense. This story got picked up by AP, and a bunch of other people followed the story, which, as you know, is a compliment for a journalist. But it was that constant seeping myself into these details of the papers that I was reading, and then actually spending that extra time going to find the actual researchers who are doing it. So that is one thing that social media has allowed me to do. Now, what happens with this is it kind of breaks off a bunch of different ways. I said that my first interest was in laboratory animals. So I started this column. The column is called Mouse Farm. And it was about me getting my first transgenic mice, taking care of them, observing them zoologically, going to conventions joining the American Association of Laboratory Animal Scientists, going to their strange confabs. I took a week and I learned how to do mouse surgery at the leading mouse farm in the world. And I guess one thing I'd like to point out about this form of media, and then particularly for scientists, this is very wide open. And the thing I needed to do was to just jump in. You know, there's no one way to jump into using social media to communicate your thoughts about your work. It's pretty easy. This site, for example, you know, it's not a long application process. It's really driven by you and the questions you're asking and your ability to write. Because we have access to all kinds of visuals, you know, you can start plunking visuals in there, which is helpful. Start thinking visually. I think you all know that. You look at the journals now, what's the space being blown on, right? It's color micro photography or something. It's giant graphs. I had a young student at UC Irvine. I taught a class there on science and medical writing. And two of them wrote, I assigned them to write large pieces of narrative journalism about some realm of science that they were interested in. And a couple of them really came through. One of them with, you know, I think something close to kind of a junior New Yorker kind of article. Can't seem to pull that up right now. Here I think maybe. Well, it's not coming up, so. So I think from the science journalist point of view, this ease of access to very dense information has made us better. I also think that it's fair for you to expect more from a science journalist now. Kind of like Gelman. I keep coming back to Gelman. Gelman was basically saying, you know, I want a little bit from you. You can't just walk across the street and expect me to educate you. I want you to read this first. And this really, this kind of social media and just basic email has made that possible. You know, I often, when I write to someone I want to research, I say, look, you know, I know you got a lot on your plate, but I'll be economical with your time, and I'll read everything you suggest I read before I drive across town to interview you. I think it's a fairly, unless you're on a daily deadline, I think that's a fairly reasonable thing to expect, is some deep drilling down into your area of science by the writer. This is, I'll kind of leave you with this because I think it's about the future of people who will be doing science journalism. So this is a wonderful piece by Louise Lau. She's a senior at UC Irvine. And it's about the use of fruit flies to do longevity research, and Michael Rose. Many of you may know Michael Rose. He basically pioneered the work on delayed reproduction in fruit flies causing major expansion of lifespan. Don't try that at home. So he happened to be on campus, and I said, well, you know, why don't you do a profile of this guy in his lab? It's the forever laboratory. He's trying to figure out a way to make organisms live a long time. So she really took it on. She took it to herself and to spend a lot of time there, getting to know his lab assistants, getting to know him, his research partners, et cetera, and she turned in this beautiful, beautiful piece. By beautiful, I mean I didn't have to do much editing. That's an editor's description of a really great piece, is I didn't have to do anything. And she was able to do everything from obviously using this ability to get graphics fairly easily, to get, this is the classic mortality, square rectangularization of mortality. But she could bring all of this stuff in fairly quickly. Now, Louise Lau is not a science major. In fact, she's not particularly that interested in it. She's into fashion design. And that's what she's going to do. But what this told me was that these new tools that we have can be learned and used pretty quickly by someone who has curiosity. I mean, if they don't have that, then I don't know what they're doing in the field. But someone who's curious and driven can use these tools to do great work and to kind of shorten the amount of time that it takes to be really in-depth about something. So I'm kind of optimistic about the next generation of science writers. I'm not particularly optimistic about ours because we're trying to pay mortgages. and these younger people are just as good as we as we are in some ways. So but I am somewhat optimistic. I think that they are going to reinvent science journalism as they go. They're not hung up on the media platforms like my generation is. You know, that it's like water for them. And so I think, you know, their task will be to learn from people like KC, okay, how do you quote somebody? How do you ascertain a fact? How do you do that? But in terms of the social media, I think they're going to take it and run with it just like Gutenberg did with the printing press. So that's really all I have to say right now about social media, unless Casey has some questions.
We were going to just take questions and maybe have a little conversation and see where people wanted to go with this, because these are really mostly scientists. I do think what Greg mentioned is important about the fact that actually most of the science bloggers I know now are scientists. More so the journalists. So all of those lines have really blurred, and they're doing some really great work. The communication is there. They can drop in movies of what they're doing, animations. So there are many ways to get out there. But I thought we would just see what questions were out there, and I'm training.